Hello everyone and welcome back to a new session of Computer Science 2. Today we are at week 6B, chapter 12, Advanced Files Operations. And I'm gonna assign you homework 6. Just to remind everybody that I graded midterm and please go ahead and review the grades. If you think you earn something that I missed or by mistake, just let me know. I have the book in front of me and it's on page, starting with page 665. So let me go to Visual Studio. Here is Visual Studio. So files, we all know that a file is a collection of data that is usually stored on a computer's disk. Data can be saved to the file and then later reused or read from the file. There are many ways or methods to save your data. Some use text files or word processors. Some use database management systems. Some use spreadsheets. Some use any other sort of database, like binary files, for example, instead of text files. Usually, you need to save the data just so the program picks up where it left where it finished or terminated the execution, whether it's a method or a program or a small task. For example, this is a text file, main.cpp. When I edit this file and I add some stuff, then I save. When I click save, all those changes has been saved in the file, saved somewhere. This way, when I close Visual Studio and then reopen it, it's gonna pick up where it left the file. So here are my changes, the new lines. And in similar fashion, whether it's new lines or actual values, like numbers, integers, characters, strings, your program needs to pick up where it left. So that's why you would need, or it's essential to use filing systems. So this chapter is trying to tell you more stuff about files and how to work with files. Just a quick refresh. We have the library. In order to work with files, we need to include fstream library, which is file stream library. fstream library. Now that I included this library, I can use the built-in methods that are provided by this library. I have fstream, which is specific to input data into a file stream. So input file stream. This allows me to only read data from a file, input from a file. And I have, for example, this is L input file. I also have output stream, L output file, which is specific to writing to a file, creating and writing to a file. This input file will fail if the file doesn't exist by default. However, output file does not fail if the file doesn't exist. It will instead create the file if it can't find it. If I tell this variable to open a file called student.txt and student.txt does not exist on my system, it will create that file. Then the topic or the chapter introduces fstream, which is general to input and output. You can use this fstream for both reading and writing from a file. You have, when you use this fstream, you have different modes when you open the file. You can open the file as append, which is appending to a file, means the content of the file will be preserved, and then everything you write to that file will be added at the end of that file. This usually, this is called a flag. This flag usually causes the file to be created if it doesn't exist by default. Then you have a different flag, which is, for example, at end. Now, at end is similar to append. It will open the file and then it will point at the end of the file. You have a different flag as well. It's called in. In is the input mode, in which usually you open the file in an input mode whenever you need to read from the file. So in means from the file in to the program. Read from a file. You have out means out to a file. You have truncate. Truncate means clear the content of the file. So open the file, clear the content, write to the file. You have the binary. You can open the file as binary mode, bin or binary. Read, write to a binary file. All these are for text files. This is for binary file. Usually you use binary files because it's easier and faster for the computer to read and write from a binary file. Because in a binary file, we don't have that bridge that converts the text into characters and then save those in the file. With a binary file, it just reads it as ones and zeros and writes them into the file instead of converting them back to characters. So it's a little faster with binary files. Let me refresh your mind on how to open a file. So this is my file. I'm gonna say lfile.open. I'm gonna say I would like to open names. Let me scroll down. Names.txt, and I would like to open this as output file. So I would like to open a file called names, and I would like to write into it. The fact that I didn't specify a path here, that means open this file in wherever my code lives. So if I right click on main and then I say, or my project, and then I say open folder in File Explorer, it's gonna open where my code lives. I have stuff from before, I'm gonna delete them. Now notice, once I execute this, it's gonna create the file. Now that it executed, notice that names has been created and it's empty. Nothing in my file. I can say L file, write something. For example, my name. I don't have to check if the file has been opened successfully because I'm in the out mode. In the out mode, this flag will cause the file to be created if it doesn't exist. However, if I am in the in mode and I say L file dot or read into, for example, lstr. lstr would be a string, lstr, and I'm opening names.txt. My file right now doesn't have anything in it. It exists, but it's empty. So when I execute, when I execute, lstr will be empty because it didn't read anything from the file. However, it was able to read. So if I go ahead and delete the file, it's still locked because I didn't close it. This is still running, so it has a lock on my file. This action can't be completed because the file is open in Windows command processor. So it's being used by a different process. I can say cancel. I can kill my program. Now I can be, now I'm able to delete it. So I'm gonna run again. Notice, well, it's not gonna tell me, but I can say if file.open. This is one way. Is open. Yep. So this is one way. File is open. Else file is not open or doesn't exist, meaning. Notice that this will tell me that the file is not open because the file doesn't exist. File is not open. This is one way of checking if the file has been opened successfully. Another way is I can just check my fstream object. If the file opens successfully, then L file, which is the fstream object, will not be null. So if it's not null, that means this will evaluate to true because it's not null. Null basically evaluates to 0. So if this is not null, means this will evaluate to something other than 0, means it will evaluate to true. So if this evaluates to true, then this will be executed. Otherwise, if open fails to open the file, then L file will be null. Null will evaluate to 0, 0 will evaluate to false, so it will execute this section. So notice, if I comment this out, I will still get the same error message. File is not open. File is not open. So this is one way. This is another way. Then I still have one way, which is provided by the library, which is lfile.fail. So lfile underneath has a flag whether it failed to open or not. So lfile.fail. If this flag or this bit or this boolean evaluates to true, means it has a failure. So if lfile.fail means cout didn't open, otherwise it did open. So run. Notice it's going to tell me file is not open because fail evaluated to true. Why it evaluated true? Because the file doesn't exist. So this is a quick reminder and additional ways to check if the file has been opened correctly or successfully. This needs to be done only in the in mode. Anytime you're trying to read from a file, you need to check if the file has been opened successfully before you read from that file. With that being said, I'm going to look at the book, see what they are trying to tell you. So one thing they are trying to tell you is this fstream from a file looks like something like this, basically. So we're going to have stream. This stream, for example, if the file has my name in it, it's going to have something like this. So let's say new text names, open it, Khalil, space, enter, Khalaf. So there is a hidden character here. There is also a hidden character here, which is the enter. So this file we are looking at in this structure, Khalil Khalaf has Khalil space, new line, then Khalaf. So whenever you're reading from the file, you need to take into consideration the hidden characters in that file. Yes, this character, the cout, well, the cin, this cin helps you go around this problem because this operator stops reading whenever it encounters space or a new line. So I can say, for example, file into lstr semicolon. When I execute this statement, this operator will start, when it opens the file, it opens it and points at the beginning of this file. So it will start reading for the first character, second character. This is the stream. Second character, third character, fourth character, this character, then it encounters the space. Once it encounters the space or a new line, it's gonna grab everything it read so far and save it in str. So if I do file character in this example into lstr into, for example, some character into another lstr, this will, let me remove these. The way this is gonna work is the new line will go to my character. So this operator, the first operator, once it opens the file, it will be pointing here, right? Then it's gonna start reading, and then it encounters a space character. So it will stop reading, it will grab whatever it read and point it in str. Then this character will try to read the next character, and it will read a new line, put it in a char, and then it will stop reading. Then the next operator will continue reading K, H, A, L, A, F. Once it reaches the end, there is a hidden character called, let's do it with the green, called EOF. This EOF, end of file character. Once EOF is encountered or is reached, then everything stops. So I go back to red. Then this operator reaches EOF. It stops reading, resets some internal flags. For example, it raises a flag called EOF, reach the end of file. It doesn't raise the flag when it reaches a space or a new line. This operator stops reading at EOF, and then the file stream will raise some flags telling its internal state that the end of the file has been reached. So that's basically how the name stream comes from, because the file you look at that looks a little understandable by a human is actually an array of characters for the computer. It's a stream of characters. It's characters, then the hidden characters, then other characters, bunch of characters, and then EOF character. So this is what the big book is trying to tell you in figure 12-1. Then the next topic is checking for a file existence before opening it, which we just demonstrated. You have 3 ways to check if the file exists and succeeds in opening before reading from it. Then the next topic is file output formatting. The same way you format with IO manipulator, input and output manipulator, the same way you use this with the cout and cin. Well, the cout, not the cin. The same way you use set width, set precision, etc. You can use it in file stream. So let me take these off, and also this. We are no longer specific with F stream and off stream, so we are learning about F stream now with modes. I'm gonna open this character. I'm gonna have, for example, a double value that says L double var. equals, for example, 1, 2, 3, 4, 5, or another 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have this. I'm opening the file in output mode because I want to write to the file. I don't need to check if the file has a failure because I know for sure that it will create that file even if it doesn't exist. I'm going to close my file. At first, I want to empty it. I'm going to keep this. I'm going to kill this. And then I'm going to say, for example, I have IOManip. So I'm going to say, hey, file, I need you to output, for example, set width. First, I need to tell it, I need it to be fixed. File, double for the first iteration. The second thing I need to do is set precision. For example, here it is. I want it as 4 decimal points. Then I can dump the data. Then I can tell it, for example, I need it as 3, 2, 1, done. So 3, 2, 1. And here I'm going to say file, or I can just see out done. And then finally, I need to close my file. So I'm going to run this. And then I'm going to open the file. Now that I closed the file, I can open the file and show you how this is the double first, the way I displayed it as is. Then I told it I need only 4 decimal points. Here it is. Then I told it I only need 3. Here it is. 2, 1, done. So you can format your file exact same the way you format cout object. The same way you use set precision with cout object, you can use it with the file, whether it's set precision or set width or left alignment, right alignment, etc. Then the next topic the book needs you to know is how to pass this file stream to methods. Usually, the method takes this file stream as reference and returns a bool. For example, let's say I have a method that opens the file. So I'm gonna take this out. I'm gonna say bool state or status equals open my file, and then I'm gonna pass this object. I will also pass, for example, double var. Now that the file has values in it, I'm able to read from that file. Then I'm gonna provide the method. It returns a bool, my file. It takes an F stream reference called a file, and it takes a double also reference because I want it to reflect in my main. So a double. As a matter of fact, I don't need, if my method is responsible to only open the file that then I don't need to pass any variables. So this is my prototype. Notice no execution statements in my prototype. I'm gonna go down. I'm gonna say this bool open my file that takes f stream reference a file does what? It grabs this file and opens names as out. The fact that I passed this as reference, a file open, this change that occurs at this statement will be reflected in main. So when we come back, to main, File will be able to write out because the changes that occurred in this method will be shown in this scope. So I can tell it open the file, and then if a file dot fail, if it failed, return false. Otherwise, return true. Excuse me. Excuse me. Ooh. So return false if it fails, return true if it doesn't fail. Now, when I run my program, it's gonna stop at the function call. Notice status is true. I can here check if status is true, do something. If status is false, do something else. And I can then read from the file. This will see out. So I'm gonna say read into double this time. Then another time. We have 4 in my file. Then close the file. I don't need this to be like this. Now save. Again, run. Status is true. First one is the whole thing that we displayed earlier. So it's in the file on the first line. The second one only has, oh, interesting. Maybe it's not reading. Do we have the file still? Oh, the file has been emptied out because I opened it earlier as out. So let's say 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3.12. Save, run again. So this is the initial value. However, now it became the first line. Oh, it's not working. Oh, you know why? Because it's out. Save again, rewrite it again. 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3.1234, 1, 2, 3.123, 1, 2, 3.12. Save. Kill it. Now save again. Now it's saved. Run. It's gonna stop at status. Open it as n. So this is true. This is the default value. Now it's the first line 1, 2, 3, 4, 5. Now it's the second line 1, 2, 3, 4. Third line 1, 2, 3. And last line is 1, 2. As a matter of fact, I can, for example, grab these and put them in a method. So if L status is true, then, for example, read data from file, and then I pass it the file again. For example, I go ahead and I say it's a void read data from file. It takes an f stream as reference, f stream as reference. Then I can go here and I say, for example, pass this as reference, double value. Here is my double value. So now go ahead and implement it. So read data from file. It takes an f stream as reference. I'm gonna call it file, and it takes a double as reference called double. And here I'm gonna just say, hey file, read one time into double. F stream. So now that this takes by reference and reads by reference and dumps it in here, I'm gonna see out L double. I'm gonna call this 0 for now. Identifier not found. Read data from file, read data from file, read data from file. Making sure that I don't have any mistakes, typos. So the default value is 0. Open the file, the status is true. The fact that the status is true, I can read now. Still 0. Now it became the first line, 1, 2, 3, 1, 2, 3, 4, 5. So it's gonna display it on this the screen, and here it goes. It displayed it as 1 to 3 only because the default is 3 decimal places. If I don't tell it fixed and I don't tell it set width 5, for example, it's gonna only show me 3 decimal points. So the next topic is it's telling you that you can use get line, get, and put with file. So exactly the same like cout. The same way you use get line in a cout statement, you can use get line in file stream. For example, under my read data from file, I can dump a string, for example, string. Go ahead and change it to string. 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 Empty for now. Then I can read it. Instead of using this operator, I can use it using the getLine function. So getLine from to. Notice the suggestions. It tells you basic iStream. I have a stream. I have a file stream. There are many types of streams. There are streams from the screen. There are streams from the file. There are streams, for example, from the network. Some server is sending me a stream of data. In this case, from which stream I need, from this stream into my string, a string variable. And the fact that it is passed by reference, then this will learn about the change and will reflect it. So read data using getLine. Run. Did it open successfully? True. Read into my string. This is the first line, get line. So it grabbed that first line not as double value, but as a string, as an array of characters, if you want to call it. But it dumps it in a string object, and it will display it. The same way I use get line, I can use get. Get takes only one character instead of getting the entire line. However, I need the get has a specific syntax, which is a member variable in the file. So a file has a member variable called get, and it should put it in a char character. So I'm gonna change this. I'm gonna say I need a character al char var. I'm gonna say it's empty for now. Single quotation for char. At least one. Okay, space. So alt char, send alt char to read data. And here I'm gonna say you now receive a character. So char var, alt char var, char var, char var. So notice, oh, I'm still displaying a string. Let's display alt char. So this get will only get one character, and the first character is 1 because 1 to 3 dot 1 to 3. So the character is 1, and it will display it on the screen. So get line, get, and put. Put will only put one character into the file, just like put will put only one character on the string, on the screen. So the next topic in the book is binary files. Binary files is another form of databases, so you can save into binary file instead of text files. So let me grab these, and we're gonna leave this. We're gonna take these out. The good thing with binary files is you don't have to use primitive data types, meaning data types that are provided by the programming language like integer, string, etc. You can use your own data type and read it and write it to a file as is. For example, let's have a struct. This struct called person. This person has string name, or as a matter of fact, let's have int age, double height. You can also use primitive data type. It doesn't mean binary files are only for your defined data types. For example, I have this f stream. I have a character. I have an integer. And I have a person, L person var. This person var, L person dot age. Age equals, for example, 30. And this person has height 6, for example, 0.2. So these are my variables, and I have my f file. Now for the binary operations, we have a write method and we have a read method. When you open the file in binary mode, you're allowed to use both of these. I'm gonna start with the char first. So I'm gonna tell my file, hey file, I need to open, for example, names.dat. Dat for data. Dat. And I need it as binary. The way write and read work, first let's prepare names. It's empty. The way read and write work, they have a specific syntax, which is the first is an address of a character. Then, so meaning like if you're reading, the first parameter is reading 2. The second parameter is how many bytes you're reading. For example, I'm gonna check if L file was opened successful. See out fail. Otherwise, I'm gonna say write. So notice the first parameter is constant char pointer. The second parameter is the stream size, count. Count in bytes, how many bytes you're trying to. So I'm gonna tell my file, I need you to write from this address, and I need you to write only 1 byte. Why 1 byte? Because characters are 1 byte. I'm gonna put K in here. I can use 1, or I can use size of L char variable, meaning whatever the size of char is. Whatever the size of char is, this is how many bytes I need. Size of returns the number of bytes, the size in bytes of the variable that you pass it. Size of, I pass the char variable, it's gonna return the size in bytes. How many bytes is a character variable? It's only 1 byte, so this will return 1 byte. So again, write from this address this much bytes. this many bytes. Now when I run, let's close the file. We're closing the file. It said fail. Why did it fail? Because names.dat doesn't exist. So let me new names.dat. Now it exists. Yes, I want to change it. So now I have names.dat. So save, run again, fail again, names.dat, names.dat. Why it's failing? Let's see. Interesting. Let's see if I did anything wrong. Okay, so it needs out as well. This is bitwise OR. So basically I'm telling it I need out and binary. I need both of them. So I need the binary and I need it to be out. Then I need to yeah, I'm opening it and then I need to write to it. It should work. Interesting. Okay, so now it works. If I right click and I say open with, I'm gonna tell it to open with Notepad. Here it is, K. Notepad was able to show me what's in the file. So similar fashion, now that I wrote this, I can tell it, hey, alchar var, I need you to be equal to nothing. Then I'm gonna tell my file to read into it. So read means similar style to write. Write takes first parameter address and second parameter size in bytes. Read is the same. Takes first parameter as address, second parameter as bytes. The address in read means into which address you're trying to read. The address in write is from which address you're trying to write into the file. So this address in this function is which address the file needs to read from into the file. In here, the address is into which address the file needs to read into. So I need to read into this address and I need to read this many bytes. Then I'm gonna say out. F10. Go. So write, I was able to write that uh, um, character. Now it's empty. So now notice, oh, it's a new line because it's pointing at the after write. When I said write, if we go back here, the stream in the file was empty first. Then I told it to write. So now it wrote K, and this is EOF. So when I executed write, this is the stream. This is how the file looks like. It wrote here. So now it's pointing here at end of file. Then I told it to read, so it read end of file. What I need to do is, what I can do actually is, after writing, I can close the file. Now that I closed the file, I can open the file again in mode. So close the file, then I'm gonna open the file again in mode. Now that I have it open or reopened, the pointer automatically started pointing at the beginning again. So now that I reopened it, the pointer is here. So I'm gonna tell it now to read. Let's step into. And actually, I need to delete it. Now run K. So I was able to write first. So I wrote K, and then I read K into my character here, and then I displayed my character after it was a space. So read, write. This is for character. Now, what if I wanna do integer? If I wanna do integer, again, notice the first parameter. When I open the parentheses, it says constant char. So what if it's an integer? The way you go around this is by telling it, you see this address I'm giving it to you, treat it as a character, uh, pointer. I'm gonna give you an address and I need you to treat it as a character address. And you do this by doing the function reinterpret cast. You cast it. So I need to cast into a character pointer, and then now I give it the address. I give it the address of my integer. And how many bytes? Whatever the size of integer variable. Let's do between parentheses. So I told it, hey, right, I'm giving you an address and I need you to treat it as a character pointer. And I need you to write from this address this many bytes. This is 4 bytes. So this will return false. Then the write will go to this address, treat it as character pointer, and it will read 4 bytes from this address into the file. So let's put 1, 2, 3. Then I'm gonna close the file. And the same way I reset this, I'm gonna reset it to 0. Now that it's reset, I'm opening it again, and then I'm gonna tell it the same way. Hey, read, I need you to read from this variable. However, I need to treat it as char pointer. Now that you're treating this as char pointer, I need you to read 4 bytes uh, uh, from the file. So size of an integer variable. Then I'm gonna display it. So this line on the screen should display 1 to 3 instead of 0. Why 1 to 3? Because I wrote 1 to 3 to the file. So let's close this. Let's delete the file. Then let's run it again. And I'm gonna see 1 to 3. If I open that in Notepad, this character is how Notepad interpreted the binary data of 1 to 3. Under the hood, there are ones and zeros that represent, in this file, in this dat file, there are ones and zeros that represent the value 1, 2, 3, whatever the binary representation is. The binary representation of 1, 2, 3 is 1, 2, 3. This how many 64s I have? I have 64 plus 32 plus how many? So 64, this is 96. 96, I still have around 16, right? So 96 plus 16, 112. 118 actually. 118, I'm left off with 5, so plus 4 plus 1. I can confirm by doing, let me open Chrome really quick. 64 plus 32 plus 16 plus 4 plus 1, 117. So I need 6. So let's take these out still. Plus 8. I need 2's complement. I can't sum up unless 2's complement, and I'm gonna explain in a minute. So how much are these? 120. Then I need only 3. So 2 plus 1. This represents in integers the value 1 to 3. The representation is you have, I'm gonna do red, all the 2's complement. Let's put all the 2's complement up to 64. So I have 64, I have 32, or if it's easier for you, I'm gonna start from here. We start by 2, then we start by 1, sorry, then 2, then 4, then 8, then 16, then 32, then 64, then 128, etc. 2's complement. Then you can think of it as switches, on or off, true or false. So I'm gonna use blue. Do we have one? Yes, we have one. True. Switch on. Do we have two? Yes, I have two. Do we have four? No. Do we have 8? Yes. Do we have 16? Yes. Do we have 32? Yes. Do we have 64? Yes. Maybe this didn't have a lot of zeros. Maybe this is bad example, but in any number can be represented in ones and zeros. It depends which values, which two's complement is included, and which two's complement is excluded. In this case, this is the bit representation of one of the value 1 to 3. So 1, 2, 3, 123 evaluates to this representation 1, 1, 1, 0, 1, 1. So Notepad as a software, we have 1, 1, 1, 1, 0, 1, 1 in the data file, in the binary file. Why it's called binary? Because it's bits. Binary means twos, means it's either 0 or 1. So in the binary file, in my names.dat, I have zeros and ones. I just wrote the value 1 to 3. The value 1 to 3 under the hood is this representation 1, 1, 1, 1, 0, 1, 1. So in my dat file or in my binary file, I have 1, 1, 1, 1, 0, 1, 1. When I told the operating system open with, and I chose Notepad, Notepad with its behavior read or interpreted 111011 as this character. And then how many spaces? One space. So the 111011 in Notepad were represented by curly open bracket plus space. I just wanted to clear this out so that you don't get confused. Oh, why did we write 1 to 3, but now we see open bracket character? You see open bracket character because we chose to open it in Notepad, and this is how Notepad interpreted the bit representation. Maybe if I choose a different software, I'm gonna see different thing. If I download a software that reads binary files, and I, for example, select the setting that I need you to write, I need you to read binary and display it in ASCII, for example, or some other representation, I might open the file using that software and see 1, 2, 3 on the screen, in the file or on the screen. So I just wanted to clear this out. Yeah, so now when we reached this, when we wrote 1, 2, 3 into the file and we closed the file, we reset integer value, we made it equal to 0. Then I opened the file and I told it I need you to open it in mode, and it's a binary mode. Then I need to read. So this is my file. Hey file, I need you to read into this address this many bytes. Now that it read this many bytes, which is 4, into this address became whatever the bit representation in that file evaluated to the type, which is integer. So it became 1 to 3, and it displayed it on the screen. This is not the right file. Go now. 1, 2, 3. So we did character, we did integer. Now, same exact sentence. I'm gonna Same exact syntax I'm going to use for the person var. Person var has 30, has 6.2. So, hey that, hey file, I needed to open that. Let's kill that or delete that. Hey that, I need you to open this file in out mode and it's binary. And I need you to write from this address, and I needed to treat it as character pointer because write takes character pointer. And since addresses throughout the system, if you remember from early sessions, my computer, all my addresses are of the same size, whether it's a start from 0 all the way to whatever terabytes are. All of them have the same size, similar to like addresses in my street, for example. Addresses in my street, all of them are 5 digits. Whether my address is 10,000 or my address is 9 9 9 9 99,999, or whether it's 9, all of them are of 5 characters. So whether the address is 0, it's basically 0. Whether the size is 10,000, it's 5 characters. So addresses in memory, whether the address is in hexadecimal, whether the address is 0000000000001 or F because hexadecimal, F, all addresses are of the same size, starting from 1 all the way to maxing out. This, for example, is 10 characters. Also, this is 10 characters. So whether I'm at the beginning of my pool of addresses or I'm at the end of my pool of addresses, all this range has 10 characters. So when this method is expecting an address, it's expecting, based on this example, it's expecting a value of 10 characters. Whether this value represents only one slot in memory or 4 slots for integer or X slots for person data, I can hack it. I can trick this method and tell it, hey, you see this? You see these 10 characters I'm giving you? I need you to treat it as character. Treat it as an address of a character, but read or write this many bytes. So if it's character, it's 1 byte. If it's integer, it's 4 byte. So imagine this as the starting address of my storage. If I'm writing, this is the starting address where I'm writing to. If I'm reading, this is the starting address of where I'm reading from, or read into, sorry. Write means write from into the file. Read means read from the file into this address. So this you as a student, think of it as the starting address. Whether it's 1 byte or 4 bytes or n bytes, this is the starting address. So, hey file, I need you to write from this starting address this many bytes. Me as Khalil right now, I don't care how many bytes are in person var. I don't have to figure it out. I don't have to think about it. I can just call size of. So write from this address, whatever the size of person var is. Then I'm gonna say person var dot age equals to 0 and height. This is for demonstrating purposes because I don't want to display whatever is the initial value. When I tell it to display age and height, if I don't have these two sentences and it actually works and displays 30, 60, 6.2, how am I going to know if it read it from the file or it was the initial value? So I'm resetting it here. I'm resetting it here. So if it displays zeros, that means the read have failed. If it actually displays 30 and 6.2, that means read worked as expected. So we did this, we close the file, we reset the values just so we can see if it worked or not. Then I'm gonna tell again, hey file, I need you to open in mode, it's binary file. I need you to read into this starting address, size of this, whatever the size of this. In this case, struct has a size of 4 plus 8. It has 12 bytes because integer is 4 and double is 8. So run. Did we kill names? Yep, we deleted names. Run. I should see 30 and 6.2. Here it is. Again, slowly. Delete. F10. F10. Go, 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 go. I need you to read, or sorry, write from this starting address this many bytes. Now that it read into the file, we can close the file and then open it. Open with Notepad, for example. Let's see how Notepad is going to represent those binary values. So it represented it as this, wherever this is under the hood. This would be something like 1010001101100001, whatever. Now that we have um, these in file, I'm gonna reset. So now L person has 0 age, 0 height. And then I'm gonna attempt to read. Hey file, open this data file or binary file in mode and in binary mode. And I need you to read into this starting address this many bytes. In my case, it's 12 bytes. Go. Now I hover my mouse, it read 36.2. You might say, hey, how did it know that 30 is for age and height for 6.2? Because it writes them from top to bottom. When I call write, it goes to my struct from top to bottom. First value is this, second value is this, and it dumps it in the file as binary, as ones and zeros. Then when I read, it's gonna read the first value and put it in the first declared member variable. So it's gonna read from the file the first value that exists and puts it in the first declared member variable from top. Then it's gonna read the second value found in the file and puts it in the second declared member variable. So every value, the way it wrote it is the same way it reads it. It wrote it top to bottom. It wrote m age as first value, m height as second value in binary representation, of course. But it also read it the same way. In my file, first value is this, second value is that. Now that it read them, I have them displayed on the screen. 36.2. The same way I did this, I can do it with vector of structs. I can iterate and keep writing. You know, iterate 10. I have a vector, for example, of structs. I can keep iterating and writing. On each iteration, I can write one struct as a whole. I don't need to write the integer of that struct first and then write the height of that struct. No, I can write and read the entire struct. If I have vector of 10 structs, I can iterate 10 times and on each iteration write an entire item from that vector. Close the file, then I can iterate 10 times and read an entire struct item from the file into my vector, and then I can display. And this is basically binary files. It's pretty straightforward. Then the next topic is 12.9, which is random access files. So let me take these out. Why this is stuck in my lungs? Okay, starting fresh. Random access. Let me delete these. Let's go to my pen and let's go size. Extra size. Okay. Right now, when you have, if you have a file, let's say this file, Khalil Khalaf. This file as a stream looks like this. It has K, H, A, L, I, L, space, K, H, A, L, A, F, end of file. That's so we make it look pretty. Something like this. So the stream in that file looks like this, exactly like this. It has bunch of characters, space, bunch of characters, end of file. Did I save? Cheer up. Yes, I did save. Usually, when you do lfile.open and you say I need to open, for example, names.txt, this is what it's called. And I need to open it as in, for example, in mode. I need to read. Once this gets executed, then the file will be open and this object, lfile, will be pointing here at the beginning. It will open the file and then lfile will be pointing here. Then if I read one character, it's gonna point here. It will no longer point at the beginning. If I say get line is gonna take the entire line. Or let's say read into a string, it's gonna, since it's pointing here, it's gonna read H, A, L, I, L. It reaches space, it stops reading. Now it no longer points here. Now it's pointing at K. So if you notice, it's linear. When we open, the access of the file is linear. We open the file, you start from the beginning, and then it starts going linearly up until the end of file. However, you can randomly access the file. You can open the file and right away, for example, I can open the file and right away point here instead of the beginning. Or I can right away point here. Open the file and point at third byte. Or open the file and point at 3 bytes before end. So this is the idea behind random access memory. You're gonna have a reference, like a reference map. You have fixed here. This is the beginning. You have a fixed reference here. So reference that points always at the beginning. You have a reference that always points at the end. And then I can open the file and tell it, hey, move from begin 5 bytes. So 1, 2, 3, 4, 5. Then when I open the file and I tell it move from beginning 5 bytes, it's gonna point here. Or I can open the file and I tell it move -5 from end of the file. So 1, 2, 3, 4, 5. Then it's gonna point here from the very first beginning. I can open the file and tell it point -5 from end. Then my file will be pointing here. If I tell it read one character, it's gonna read H. If I tell it read into a string, it's gonna start linearly. It can stop reading at end of file. Then I can tell it again, move -10 from end file. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's gonna go back and point here. It's not gonna terminate everything when it reaches end of file because I told it to go back. I can reset, for example. Once it reaches EOF, I can tell it move to begin. Then it's gonna point here. This is the idea. So let's see the code. The methods that you're gonna use are seek p, which is meaning seek to put, seek in order to put. You're gonna have seek get, seek g, which is seek to get, and seek in order to get. So seek in order to put, seek in order to get. And you're gonna have tell p, tell me tell me the position of put. So there is both put and get behavior. Just like read and write that you see earlier, there's always a put and there's always a get. You control the put by seeking p, and you control the get by seeking get or seeking g. You can ask your file to tell you where the put pointer is pointing, and you can tell it to tell you where the get. Tell me the position of get. In other words, tell me where put is pointing at in terms of position. Tell me where get is pointing at. Okay, and then I have my references, my fixed references. I have iOS big for beginning. I have iOS end for end. And I also have additional one called current, meaning if for whatever reason my pointer is here and then I tell it, for example, read one character, it's gonna read the character and then it's gonna point here. So current is wherever the current pointer is pointing at, whatever the current position is. For example, move 2 from current. Instead of telling it move 2 from beginning or move -2 from end, I can tell it move 2 from current. So it's going to point here, or move 2 or move -2 from current. It's going to point here, etc. So I have 3 fixed reference pointers. So this is the idea. And then I'm going to show you some code. So now I have, this is opening. I can tell it, for example, we can tell it, hey, file, I need you to seek, let's get first. I need you to seek get. I need you to move 5 from begin. 5 bytes from big. Now that it's pointing at the 5th byte or 6th byte, I'm gonna tell it, hey, file, I need you to get into char variable. And then I'm gonna display char variable, char var and l. So let's declare char var. I'm gonna give it space just so we see how it's gonna behaving. So look, I opened the file. I'm gonna tell it seek 5, seek to get, seek in order to get, move 5 bytes from beginning, and then get char. Char is L. If I open my names and I count, I opened right here. Here I opened the file. Here I opened the file. So it opened the file and it pointed at the beginning. Then I told it, see, get 5 from begin. So 1, 2, 3, 4, 5, fifth bit. Now that I told it get this L, sorry, this L. So move 1, 2, 3, 4, 5. Now it's pointing at the L, and I told it read one character, so it read the L. So now it's gonna display it. It displayed it. It's gonna close the file. Here you go. So for example, I can, after seeking, I can tell it, hey, L file, let's reset char first. L char var equals space. Then I can tell it, hey, L file, I need you to seek get, for example, -5 from iOS end. And then, hey, L file, read or get into L char var, and then display it. See out L char var and L. Now that I did this, I can redo it again. So let's group them together. Now that I did this, I can again reset. For example, this time I need you to move 2 from current, wherever 2 from current is. So let's see how this behaves. No, I need you to start like this. Yep. Step in. So move 5, I thread L. So now it's pointing at here. It thread it. So now it should be pointing at the space. Then, despite that it is pointing at the space, I told it I needed to move -5 from end. So this is end, move -5. 1, 2, 3, 4, 5. So now it's gonna be pointing at the K. So move, read, it read H, which is after the K. So here at H. Then I told it move 2 from current. Now that it read H, I believe it's pointing at A. Seek get 2 from current. So it's pointing at A. It's gonna move 1, 2. It's gonna read A or F. Oh well, A. Okay. So now it's moving. It's doing what basically I'm telling it to do. I'm jumping randomly, just like how we have earlier. We have it like, okay, move here, then move back, then move 2 from current, etc. So random access to the file. Also, in the same fashion, I can put instead of read. Well, I need to open it in both iOS. I believe I can do it like this. So seek put, seek get. Actually, before we do the put, I can see out, for example, tell get, hey, L file, tell me which byte are you pointing at. Let's reach this one. And then finally, it displayed the A, the second A. So it displayed this, it should be pointing at F. F is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13th byte. So if I tell me get, it should display 12. So it's at the 12th byte from 0 maybe. 0, 1, 2, 3, all the way to the 13th. It told me which byte it's on using the tell get. Same fashion, I can again tell it, hey, I needed to move -4, for example, from current. And then I'm going to tell it to seek put. So seek put -4 from current. And I need you to put the character, for example, capital B. And then I'm going to close the file, and then we're going to open the file together and see what's in it. So go. Okay. So seek put from The last one was 12, right? So it was 12, and I'm gonna close. So 12, it moved -4, so that's 8. If I open now, I should see B. So it was here at the 12, then it moved 1, 2, 3, 4. It was pointing at the H, but I told it to put B. So it replaced H with B. I put in a random location, not random, but based on what I told it, it put B instead of H in the place that I told it to move for from current. I can also then tell it, hey alfile, seek, put 2 from begin, right? And then, hey alfile, I need you to put, uh, this time I need, like, for example, capital T, and then close the file. So go, close the file, open the file, or reopen the file. Here it is, 2. So 2 from begin, 1, 2. Well, it was pointing at K when it opened the file. So I told it move to 1, 2. So now it's pointing at T, and I told it to put T instead of the previous A. So this is random access topic. The next topic is opening both for input and output, which is what I just did. This is how I open for both input and output. And this is it for the chapter. So I'm going to assign you homework 6, which is related to this. And let me know if you have any questions.